Okay, this is 4.3 multiply matrices. So got an example here. 2014 regular season, and I went through and made a chart. And so you got the Redskins, because all you Redskin fans. How many are Redskin fans in here? I'm just curious. Wow, that is so low for living in this area. All right, who could care less about the NFL? I'm just curious. Okay, so the rest of you are some other fans? Okay, all right, just wondering. Just curious. I'm a Giant fan, I am a Cleveland Brown fan, and I am a Washington Redskin fan. The Ravens weren't in Baltimore when I was there, otherwise I would be a Baltimore Raven. I'm always a fan of where I am, but anyhow. All right. Redskins, 33 touchdowns, 31 extra points, no two-point conversions, 24 field goals. That was last year. The Bears, any Bears fans in here? I'm just curious. No Bear fans, all right. That's because Mr. Cormican loves the Bears, and you just got to go against him, right? All right, just wondering. So 40 touchdowns, 33 extra points, 5 two-point conversions, 12 field goals. And the Patriots, any Patriot fans in here? All right, a few of you. Okay, just curious. Super Bowl champs last year, 52 touchdowns, 51 extra points, no two-point conversions, and 35 field goals. I guess the bottom line is with the Bears, they needed all those tries for the two-point conversions, and nobody else did. All right, and then on the right-hand side, I made a table of the value, right? A touchdown in the NFL, in case you didn't know, it is 6 points, and an extra point is 1, and a two-point conversion is 2, and a field goal is 3 points. How many of you, I think all you guys do this in one class or another, where you make charts off of data in Microsoft Word or Excel? Yes? So you should be familiar. Pretty easy to do. All you do is click on the table, and it'll basically take care of everything for you. All right, so we want to take this data, and we want to make some matrices of it. So we're going to make a matrix S, and we're going to do scoring. So I'm going to take the top row, and I'm going to do the skins. So the top row is going to be touchdowns, then extra points, then two-point conversions, and field goals. All right, so 33, 31, 0, and 24. Nothing today, thank you. And I'm not going to do yellow because that's not going to show up, so I'll do the Bears in black. So second row is going to be the Bears in 40, 33, 5, and 12. And the last row is the Patriots, 52, 51, 0, and 35. So that's our scoring matrix, right? Just going right off the table, right? First row, second row, third row. And then I'm going to do a matrix for the point value. And this is just a 6, this is just one column, right? 6, 1, 2, 3, just like you see the data represented. 6, 1, 2, 3. Okay, so first matrix. Hopefully you agree that the scoring matrix is a 3 rows, so it's a 3 by, and it's got 4 columns, so it's a 3 by 4. And you look at the second matrix, and it's got 4 rows and only 1 column. All right, so what we want to do down below is we want to multiply the matrices. We want to multiply matrix S times matrix P. So I think it was Friday, we did scalar multiplication. It's pretty easy, a number times a matrix, and you just distribute it to every element in the matrix. Pretty easy. Now we want to do matrix multiplication. So now we're going to multiply a matrix times a matrix, and it's a different animal. And you just got to learn the pattern. So be careful. You just got to get the pattern down, and if you don't get the pattern down, you're going to miss every one. If you get the pattern down, you still got to be careful because it's a little bit tricky. All right, so let's see if we can do matrix S times matrix P. Let me go a little higher for you guys for right now. All right, so this is what we've got to do. I'm going to take my red here. I'm going to do a parentheses. So the first one would make sense. We're going to go 33 times the 6. And I'm going to keep trying to switch my colors here to make sense for you. So we took the first one, the 33, times the first one, the 6. I'm going to go back to red again, because what I'm going to do is I'm going to work all the way across the top row. And I need a plus sign here. And I'm going to go now to the second element of the first row of S, and that's the 31. And I'm not going to multiply it times the 6. I'm going to work down the column. So I'm going to multiply it times the 1. The 31 times the 1. The second one across times the second one down. I'm going to take my red again. I'm going to do this 0. And just to be clear, the third one across goes with the third one down, so that's 0 times 2. And then take my red one more time and do plus. And now it's going to be 24 times the 6. Times the 3. Good. Paying attention. Awesome. Right, fourth one across times the fourth one down. Okay, we did the first row. So what would make sense now, because math is orderly and math always makes sense, what would you do next? What do you think would be next? Abigail? Do the exact same thing for the second row, right? First times the first, second times the second, and you're adding as you go. So this is a 40 times a 6 plus a 33 times a 1 plus a 5 times a 2 plus a 12 times a 3. And again, we got to be careful because anywhere along the way we could look off and be off, and we don't want to do that. So third row, same thing, right? Notice we're working across the row, down the column. So the third row is going to be the 52 times the 6 plus the 51 times the 1 plus the 0 times the 2. And finally, plus the 35 times the 3. Okay, so now you got to work your way all the way through this. And you got to do element by element. You got to add it up. And let me close my parentheses here on this last one. So the top one is 301. I'll save you the math. And the middle row is 319. And the bottom row is 468. And notice the regular season total points. The Skins had 301, the Bears had 319, and the Patriots had 468. And it makes sense. That's what we were doing. We were taking what they did in each category and multiplying it times the number of points for that category. And we accomplished that by multiplying the matrices. And that's what happens in real life. So when I made this up with the final chart here, this one over here, what I had to do was I had to stick a formula in there. Unfortunately, there was not, that I knew of, an array formula to multiply array S times array P. I wish there would have been. If there would have been, it would have just, bang, shot that out. And maybe there is, I'm just not aware of it. I had to literally go through and tell it to add, you know, sell this times that plus sell that times that, etc., to go ahead and make up this chart. I'm sure there is a command, and I'm sure it's there, because all it simply is multiplying the S matrix times the P matrix. And what do? You end up figuring out their total points regular season scoring. Multiplying matrices. So that's what we got to do this chapter or this lesson. You got to multiply matrices. So let's go through and, oh, let me back up 1 second here. One other thing of note. So what do you end up with? You end up with 3 rows and 1 column, right? You end up with something that's 3 rows and 1 column. My magic pen didn't give me my oval. So we started with a 3 by 4 and we multiplied it times a 4 by 1 and we ended up with a 3 by 1. Do you see a relationship? Right? 3 by 4 and a 4 by 1 and we ended up with a 3 by 1. And there is a relationship and we'll talk about that right now. All right. So to multiply matrices, in order to even do this, the matrices, to multiply them, you have to have columns of the first must match the rows of the second. The columns of the first must match the rows of the second. Was that the case with our matrices? Yes. Right? We had 4 columns in the first matrix and 4 rows in the second matrix. You can't multiply them unless those match. So if they ask you to multiply matrices and the columns of the first doesn't equal the rows of the second, then you cannot multiply them. You can't do them. So let me pause real quick and ask you a simplistic question. Is multiplying of matrices commutative? Is multiplying of matrices commutative? Anybody have an answer? Is multiplying of matrices commutative? So let me restate where I was. In order to multiply matrices, the columns of the first must equal the rows of the second. Columns of the first must equal the rows of the second. Are multiplying of matrices commutative? Why? How many agree with Hunter? Yeah, and if you were listening, it's exactly the point, right? If you now flip the 2 matrices, the column of the first is going to be 1, and the rows of the second is going to be 3, and you can't even multiply them. You can't even multiply them, so how in the world could they be commutative if you can't even reverse some matrices and multiply them? And that's the reality is you can't, and it's definitely not commutative. All right, commutative doesn't work for every kind of situation, for every kind of operation, and it doesn't work for multiplying matrices. All right, so multiplying matrices, columns of the first must match the rows of the second. But not only that, what will the product be? Did you catch it from the earlier example? If you multiply a 2 by 3 times a 3 by 4, you end up with a 2 by 4 every time. And this is just common knowledge that every student should know. Any 2 by 3 times a 3 by 4, you end up with a 2 by 4. Hopefully not square in the forehead. All right. So 5 by 2 times a 2 by 7 is going to end up with a 5 by 7. It's got to be, has to be. That's the way it goes. Okay, so I hinted at the pattern earlier. Remember, you got to work across the row. And you have to work down the columns. So you're across and down is what you got to get in your mind. Across and down. Across and down. So in order to multiply, the columns of the first have to equal the rows of the second. The product will be the rows of the first, columns of the second, right? The outside numbers. And how do you do it? You work across and down. So let's see if we can do New Jersey here. So we got matrix 1 and matrix 2. So this one's a little bit more complicated than the first example. So I'm going to use my red here. So you should be able to start this one, right? My first multiplication would be a 1 times 1. Do you agree? Somebody raise your hand. What would be the second multiplication? So what's next? Luke? A plus of 4 times 2, right? Across and down. Now I finished that column, right? So I'm going to close the parentheses. That's one number. We went across the first row and down the first column. Now I'm going to keep working my 1 and 4. So next I'm going to do 1 times, what would be logical here? 1 times 0, exactly. And then it's again going to be plus 4 times. And again, try to think this through. And if you're not following, ask a question so we can get it, right? We went across and down. So now we went across the top row and down the middle. 1 times 0, 4 times 1, right? Across and down. So now we're still working across. And this last one is going to be a 1 times 7 plus a 4 times negative 3. And that's all the first row. Which, by the way, let me pause a second here. Let's go back and understand that we're dealing with the 2 by 2 in the first matrix, right? And we're dealing with a 2 by 3 in the second matrix. Thank you. So 2 by 2 and a 2 by 3, right? So we're expecting our final answer to be a 2 by 3, right? Okay, can you do the second row? Want to try it? Because we just did the first row. Look, would you agree the second row is going to start off with a 2? And what would you multiply the 2 by? 1, right? I'm going across the bottom row now and down the first column. Plus a negative 3 times a 2, right? And that's going to be the first one. I went down that first column. Now I got to go down the second column. So just keep working your way across. 2 times 0 minus 3 times 1. And now I'm going to work across that last column, crossing down 2 times 7 and minus 3 times a negative 3. All right, for time's sake, this all boils down to a top row of 9, 4, negative 5, if I count it right, and negative 4, negative 3, 23. And sure enough, we ended up with a 2 by 3, which is what we were expecting. So 9, 4, negative 5 is the top row. Negative 4, negative 3, 23 is the bottom row. We went across the rows and down the column. Across the row and down the column. Across the row and down the... Across a row and down a column is one number. When you go across a row and you go down a column, the result is one number. Across the first row and down the first column gave us the 9, right? Across the first row and down the middle column gave us the 4. Across and down gives you one number, one element of the resulting matrix. Any questions so far? Okay, so I really need to give you guys a shot to see if you can figure this one out. So I think I can give you about 5 minutes. I'm going to pause this. All right, so I don't know where you ended up. Let me unfreeze this. So I don't know about how you did yours, but to be honest with you, I did 3, negative 1, plus 2. I left it blank. I did 3, negative 1, plus 2, left it blank. Then I filled in the 3, 1, negative 1. Then I filled in the 2, 5, negative 3. And I left the bottom half done so that you'd see what I did. So again, I knew the bottom row was 1, 4, negative 2. So then I'm going to fill in the 3, the 1, and the negative 1, right? And then I'm going to fill in the negative 2 and the 5 and the negative 3, right? Because you're working across and down. All right, where do we end up? I think 6, negative 17, 9, 24. Anybody concur? Okay, hit the back. How many got 3 of the 4 numbers correct? At least 3 of the 4. Let me see your hand if you got 4 out of 4, you got at least 3 out of 4. Let me see your hand if you got at least 3 out of 4. Okay, which means you simply made a mistake on that 4th number. You got 2 out of 4, okay, so you made a mistake on 2 of the 4 numbers. You're working across and down. Across the first row, down the first column. That's your first number. Now, again, you got to be able to multiply positives and negatives, and you got to be able to add positives and negatives. And so there are what? 1, 2, 3, 6, 9, 12 multiplications, 12 additions to finally give you the right matrix, and you got to know what you're doing in process. So you got to go 24 for 24 on the math, and you've got to know what you're doing. So be careful. I will try to give you some partial credit on these, meaning if you miss one number out of all of them, I won't take all the points off. But honestly, in math, you know, if you were really close and you're doing somebody's finances, they're not going to be too happy that you were really close most of the time. Okay? They're going to be upset that you missed it when you did, so be careful. All right, we'll figure the rest of that out tonight. Let's do the last page here. All right, multiplying by the multiplicative identity matrix. Identity. The multiplicative identity matrix. It gets you back, as you would expect, to the identity gets you back to the original. Thank you. All right, we're going to use this later on in solving some matrices. So right now, we're not going that far, but that's where we're heading down the road. So we're just kind of setting it up right now. Here's one fact: only square matrices have an inverse. Not everything has an inverse. We'll see that later on in functions as well. Not every function has an inverse. We'll learn some techniques like restricting a domain to make that happen. So again, this is identity. Only square matrices have a multiplicative identity matrix. The pattern's not too hard. It's basically a 1 in the top left corner, as well as on the diagonal. So it's a fairly simplistic pattern. All the other elements are 0. So you got a 1 top left corner, and then down the diagonal, and then everything else is 0. So the two most popular ones, because again, we're human brains and we do small things. So you got to have a 1 in the top left corner. You're going to go down the diagonal, so you have another 1. And then your other 2 elements are zeros, right? And that's the identity element or matrix for a 2 by 2. So a 3 by 3 is real similar. You need top left a 1, the middle a 1, and the third column bottom a 1. So we got 0, 0, 0, 0, 0, 0, right? So if you're going to write it out, you were just writing it, you do 1, 0, 0, 0, 1, 0, 0, 0, 1. But again, notice the pattern. Top left corner is a 1. Go down the diagonal with 1s. If it would have been a 4 by 4, again, you'd have one more 1 down to the bottom right, and the rest filled in with zeros. You just keep going down that pattern, down that pattern, down that pattern. Okay, so our time's getting limited here, and we're probably not going to finish this. But if we took this matrix, a 1, 4 first row and a 2, negative 3 second row, and we multiply it times its identity. So 1, 0, 0, 1. I know I'm going fast. Sorry about that. So you got a 1, 4 times a 2, negative 3 times a 1, 0 times a 0, 1. Okay, I'm going to go kind of fast. Across and down, right? 1 times 1 plus a 4 times 0, right? Crossing down. That was across the first row and down the first column. Across and down. I'm still across the top row. 1 times 0 plus a 4 times 1. Working the bottom now. Across and down. 2 times 1. I'm going down the first column. And a minus 3 times 0. Across and down. 2 times 0. And minus 3 times 1. Add it all up. What do you get? 1, 4, 2, negative 3, if we did everything right. All right, you're back to the original. We better be. Add it all up, you get a 1, 4, 2, negative 3. If you multiply any matrix times its identity, you're going to be back to the original. Okay, crossing down. I know I did that last one fast. Sorry about that. Okay, last thing. And again, we're going to use this later on to solve matrices, systems really. And this system is a 3 by 3. So write the system as a matrix operation. So all you're going to do is take the top equation. And by the way, everything's lined up already, right? You have first equation, x, y, z equals a number, a constant. Second one, the y is first, the x is first, the y is second, and then the constant's on the right. And the third one, the x is first, the y is second. The z is on the right, and the negative 6 is not. So that's the only one we better rearrange, right? So before we do anything, let's rearrange. Let's add a negative 5z to both sides, and let's add a positive 6 to both sides, right? Is everybody okay with that? All I'm doing is getting everything in order. Okay, now it's just a matter of writing the coefficients. Here, I'll use red on this first one. So the first matrix, just going to be the coefficients of the variables. So the top row, 2, negative 3, 1. Right, a z is a 1z. Middle row, 1, negative 1. What do I put next? Nothing? Do I leave a hole? Got to use a 0. You got to plug that hole with a 0. So that's got to be a 0. I'll do the bottom one in blue here. So you got, what, a 3, a 4, and a negative 5? Okay. Now what you do is you have right next to another matrix. And this is going to be our variables, x, y, z. It's one column. It's a column matrix. So we have a 3 by 2 times a 3 by 1. And what would you expect as the result? Well, you would end up with a 3 by 1, which is simply the solutions to the 3 equations. We wrote the system as a matrix equation. So get everything lined up and just using the coefficients as your first matrix, the variables as your second, and what they equal, you're equaling as the third matrix. All right, my time's up. You see the homework there at the bottom of the page. Focus now. Quiz coming up on Wednesday, so pay attention. Get the pattern down tonight. You got to get it down tonight. Get the pattern down tonight. Don't go past tonight without having the pattern down. Get the pattern down tonight.